Lesson 11.3, Equations in Two Variables. The solution of an equation in two variables is an ordered pair whose values make an equation true. For example 1, we've seen something like this before in 11.1. This is where we make our chart. There's our 3-column chart. So at a bowling alley, it costs $5 to rent shoes plus $3 per game. This is the equation we're going to use. Which table shows the possible total cost for bowling? So we're going to use the values for G. Again, this is usually called your X, and the C is usually called your Y. So this would be Y equals 5 plus 3. And then this would be X. So you'll usually see it with Y's and X's. But in this case, G is 1. So we're going to substitute 1 in for G and multiply. 3 times 1 is 3, plus 5 is 8. So you get an answer of 8. Plug in the 2. Oh, by the way, these are ordered pairs as well. Here's your X, here's your Y, 1, 8. Plug in the 2. 3 times 2 is 6, plus 5 is 11, so you have 2, 11. Then plug in the 3, 3 times 3 is 9, plus 5 is 14, 3, 14. 4 plugs in, 12 plus 5 is 17, which is 4, 17. If I wanted to graph this, I could now, because I have ordered pairs. The correct answer, because the correct table would have been B. Example 2, we're going to check some solutions. So it's going to ask you whether this solution 5, negative 8 is the solution of 4x minus y equals 12. Sometimes on your practice papers, they may give you the semicolon and then put down the ordered pair. That's just saying that this is the x, this is the y. Plug it in for this x and this y, and see if it equals 12. So I plug in for x, I plug in 5. For y, I plug in 8, negative 8. This is 20, order of operations here, minus negative 8. You know, when you have subtracting a negative, it's actually adding, so it's 28. 28 does not equal 12, so it is not a solution. You can even just put no or not a solution. This question mark is just asking you, is it a solution? It's not a solution. Example 3, we're going to find solutions of an equation. Write the equation 6x plus 2y equals 16 in function form. Then list 4 solutions. Alright, first let's talk about function form. Function form is y equals ax plus b. Write that down. Y equals ax plus b. Now there are many forms to function form. This is the basics. Y equals ax plus b. But if b is 0, you technically get rid of it. So it's just y equals ax. If a is 0, then you may just be left with a b. Okay, because 0 times x clears. If a is 1, you may see it written like this. So again, this is all kind of function form. Just know that this is a 1 here, so there's a 1 there. Okay, but it will just be an x plus b. But this is the basic. So we call this rewriting the equation. And how we do that is we're trying to get y by itself. This is probably the hardest thing about algebra, is manipulating these numbers and these variables so that y is by itself. Think of y as being glued down to this side, so we cannot move y at all. Don't move the y at all. What I would move first is the x term. That's this entire 6x. And I would add the opposite. So this is a positive 6x, so let's add a negative 6x. It's going to be 0. Go to the other side of the equal sign, add it there. Okay, this clears the left side. You're left with the 2 and the y. See how I'm going to bring down the y exactly where it is? I cannot, do not combine 16 and negative 6x. One has a variable x, one does not. So I'm just going to rewrite, basically write again, the negative 6x plus the 16. I did try to put my x variable term in the front. Y is still not by itself. This needs to be a 1 in front. The coefficient needs to be 1. Because of that, I'm going to get rid of the 2. There's the inverse operation of multiplying by 2 is dividing by 2. Divide by every number, every term. This clears to y. That's a good start because we want y by itself. Negative 6 divided by 2 is negative 3x, plus 16 divided by 2 is 8. This is my function form, the equation I want now. How they actually do it in the book is very similar. They subtract, which is adding the opposite. Again, this is adding opposite. So you can see this is adding a negative. And then divided by 2, you get the same thing. I know there's a subtraction here, but it is the same thing as adding a negative. And just so you know, I can write this, I can flip the 8 and the negative 3. It's still going to be the same. Okay, that's exactly the same. Now I'm going to make my 3-column chart. They didn't actually tell me what x's to use. Because they didn't tell me, I'm going to use negative 1, 0, 1, and 2. So here's my negative 1, 0, 1, and 2. I'm going to plug that in for the x. So this was y equals 8 plus negative 3x. And I am going to change this to adding a negative. So let's change all these to adding the opposite. Negative 3 times negative 1 is positive 3. 8 plus positive 3 is 11. Plug the 0. Oh, and this is an ordered pair, so you can get a solution. Negative 1, comma 11. Plug in 0. Negative 3 times 0 is 0. Plus 8 is 8. 0, comma 8. 1 into the equation. Negative 3 times 1 is negative 3. Plus 8 is 5. 1, comma 5. Plug in the 2. Negative 6 plus 8 is positive 2, so 2, comma 2. So here's my 4 solutions to that equation, 6x plus 2y equals 16. Generally, an equation involving 2 variables has an infinite number of solutions. It just depends on what value you put in for x. But we are always going to, if they don't tell us, we are always going to use negative 1, 0, 1, and 2 so that we all get the same answer. For number 1 and number 2, you're going to tell whether the ordered pair is a solution of the equation. Here's those semicolons I was talking about. So this, in parentheses, is your x and your y. So you're going to plug that in to the x, put parentheses around it to still represent my multiplication. Does that equal 7? Okay, so this is kind of like a question mark. Does it equal 7? So let's multiply this side. Negative 3 times negative 4, positive 12, minus 5 is indeed 7. It is a solution because 7 does equal 7. Number 2, I don't need to change anything because here's my semicolon, so here's my x, here's my y. Plug in negative 1 plus negative 7 times negative 14. Does it equal negative 7? 14 times negative 7 is going to get you an answer of 98. Plus negative 1 is definitely going to be 97. It's not going to equal negative 7. It's not a solution. Three and 4, you're going to list 4 solutions of the equation. Remember, you're going to make the 3-column chart. So here's my x, here's my y. Your x is going to be negative 1, 0, 1, and 2. And now you're going to plug that in to this equation. And you can kind of just leave the y up there. Negative 5 times negative 1 plus 11, get an answer. Negative 5 times 0 plus 11, get an answer. Negative 5 times 1, so I'm just substituting this in where the x was, plus 11. You can see I kind of stay in the same column right underneath of each other so I can line it up very nicely. By the way, once you get your answers, the solution is technically the ordered pairs that go with it. So this is the solution. So go ahead and solve number 3, and then I will set up number 4 for you. Number 4, you need to rewrite. We call it, I say rewriting, or you can say solve for y. First thing I would make sure I do is change the subtraction to adding the opposite. Now remember to clear the x term first by adding the opposite to each side, and then divide by the coefficient negative 3. Once you get your equation, y equals whatever it is, you plug it in to the chart, just like we did at number 3. Pause the video, please finish number 4, and then see Mrs. Shea so she can check, or a teacher to check your answers.